Okay, our final EOG review video is on statistics, and in Math 8 we do a little less statistics. It just focuses mostly on scatter plots and lines of best fit and two-way tables in Math 8. So let's go ahead and get started. So this is the note sheets that you should have, and we're going to start with the middle one, which is bivariate data. And bivariate just means data that has two variables. And this data is usually represented in a scatter plot, and this guy right here is a scatter plot. A scatter plot is on the X and Y axis. It's 100% of the time it's just in quadrant 1. And we call this data here, we call this clustering. You'll see that word used on the Math 8 practice and on the Math 8 test. Clustering just means how is the data grouped together. That's all clustering means. So let's take a look at examples of clustering. So clustering just means data or dots that are grouped together. So when you're comparing two variables, we look how the data is grouped. And if the clustering looks like it has a downward, it's in this case, one variable is increasing and the other variable is decreasing, that's where we're going to get a negative correlation, and it kind of looks just like slope. So this has a negative correlation because the data is clustered downhill. A positive correlation is when the data is clustered uphill. That's when both variables are increasing. So we can look at this as having a negative correlation. It has a negative slope for this first one. This one has a positive correlation. Or we can also look at it as a positive slope. Now if you can't tell, if there's no clustering, if the data points are all over the place, like on this one right here, this one has no correlation. It means there's no relationship between the data points. They don't make any sense. There's no relationship. A positive correlation would be like something like the more you study, the higher your test grade. A negative correlation would be something like the more you drive, so the more miles you drive in the car, the less gas there is in the tank of the car, and we're talking about a car that uses gas. And no correlation would be your, say, your shoe size and the number of cats you own. That's data that would have no correlation or no relationship. Okay, moving on. So we can use this data, the positive or negative correlation or clustering, to find a line that passes through the center of the data. And it's used to make predictions about the data. So if we want to draw the line of best fit for this data, we would draw the line. We want to make sure that the line goes through the center of the data, half the points above the line, and about half the points below the line. And you want to make sure it passes through 2 points on that data. And for our example, it's going to. So we want to make sure that our line of best fit, that was not a good one, goes through the center of the data. About half the points are above the line. Half the points are above the line, and we are passing through more than 2 points. And so again, we did this before, and we did this if you want to draw a dotted line above and below. You want your line of best fit to go to the center. So we want to find the slope of the line. We know that this slope is going to be positive because it's going uphill, and slope is just rise over run. So if we pick 2 points, and I'm going to try to pick points that are relatively helpful to use. Let's make this a little bigger so that we can see it. And so the points that I chose, none of them are integers, are 0.5 and 3, and then 5 and 6.5. So I'm going to find the slope of that line is the change in y over the change in x. I'll write the slope down here because we have more room. So it's 6.5 minus 3, which gives me 3.5, and then 5 minus a half, which gives me 4.5. And let's go ahead and change that into a decimal. And it rounds to about, it comes out to be 7.7, so just for our purposes we'll round it to about 0.8, which as a decimal is 4/5. So our slope for this line of best fit is 4/5. And if we look at our y-intercept on this graph, our y-intercept is about 3. So our equation for the line of best fit is 4/5 x plus 3. And we use this equation to make predictions about the data. And again, this line of best fit is just an estimate. The easiest way to get this line of best fit and the most accurate way is to do it on the calculator, and we'll take a look at that shortly. Our next section on bivariate data is using the calculator to find the line of best fit or find the trend line for a set of data. So the easiest way to do this is to enter the x in list 1 and the y in list 2, and that's where you do stat and enter. So you're going to enter the list 1, enter the x values, list 2, enter the y values. Step 2, you're going to go to second y equals enter, enter. It turns on plot 1 so you can see the scatter plot. Zoom 9 lets you see the whole thing. Step 4, we need to find the linear regression, so stat calc 4, enter, enter. It finds slope A and the y-intercept of the line of best fit. So go ahead, enter this into list 1, this into list 2, and then check your answer for the line of best fit right here. Pause the video and check your answer. Okay, so when you put this data in the calculator gives you a slope, we're going to round here, of about 76 hundredths, and a b value of 2.2. So as a equation for the line of best fit is 0.76x plus 2.2. So I can use this equation to estimate. If I wanted to know if x is my days and y is my number of TVs watched, or hours of TVs watched, if I have at 12 days, which is x, how can I figure out how many hours of TV I watch? And I'm just going to take out x, and I'm going to plug in 12. And we can use that lines to make prediction about the data. And finally, two-way tables. This is a frequency table. It is not a relative frequency table because it doesn't have percentages, but we're going to use they're used to record and analyze the relationship between two or more categorical variables. And categorical means it's a category. So the category is, yes, you have a cell phone. No, you don't have a cell phone. Yes, you have Snapchat. No, you don't have Snapchat. So we're going to go ahead and finish filling in this table. If our Snapchat total is 50, and of those 50 people, 27 people have a cell phone, how many people do not have a cell phone? So maybe they're using it on their iPad. And that would be 23 people, because this column has to be a total of 50. So no cell phone users, those who have Snapchat are 23, no Snapchat is 5, so the total cell phone users is 28. And if we know that the total number of people surveyed is 86, what can we add to 28 to get 86? And that's 58. So then 27 plus what number will give us 58? That's 31, and this will give us a total of 36. So what percent of cell phone users also have Snapchat? So we're just looking at cell phone users. So cell phone users is 58, which is this number right here. And of those 58, what percent of those 58 also have Snapchat? So of those 58, 27 have Snapchat. So as a percent, that is about 46.6%. Second question, what percent of the people surveyed? And this should say surveyed. And those people surveyed are 86. So of those 86 people that were surveyed, how many of those do not have Snapchat? So no Snapchat would be 36. And as a percent, that is about 41.9%. Okay, finally, you need to answer questions 1 through 4. You're going to need your calculator for a couple of these, especially for number 1 to find the line of best fit using the calculator. Number 2, find the line of best fit using the table. Number 3, use your line of best fit to make predictions. And number 4, complete the two-way table and then answer questions B and C. And Yahoo, that was our last video of the school year. Yay! Hand clap, hand clap. Have a good night.